Hello and welcome to Yeyu Lab. Today we will continue our series on developing real-time applications with Gemini 2.0 and its Multimodal Live API. This experimental API is so powerful that provides developers with the experience of natural human-like conversations with the ability for handling interruptions. And it can process text, audio, and video input, and it can provide text and audio as output. By leveraging this API and the performance of Gemini 2.0, we have built a lot of real-time web apps and assistants, including chatbot with video camera, screen sharing assistant, and an interactive drawing canvas. Today, we will build a real-time RAG assistant with Gemini 2.0 Multimodal Live API, which will be able to answer questions about a set of documents, and that is the literally talk to your documents. You have to agree that RAG, which is Retrieval Augmented Generation, must be one of the most valuable enhancements of language models. By its context-aware answers, it is proven as an effective approach to handle questions or tasks about up-to-date information, open domain knowledge, or proprietary data source like company sales record, customer service logs, and so on. However, when I try to examine the documents of Gemini's Multimodal Live API, I found that there's no built-in interface for document retrieval like OpenAI Assistant, so I have to build a custom process to receive the voice audio from the user retrieval and content from a set of documents and let the Gemini 2.0 to generate answer in audio format based on the document retrieval result. So today we will build a real-time RAG assistant with both front-end and back-end design. This is the usage experience of our final demo. Currently we only support the PDF file upload and the basic semantic search techniques because it's better to keep the demo simple and easy to understand. With the key features implemented, you can easily extend the application to support more file types and more advanced RAG techniques. So let's firstly upload a PDF file. Okay, PDF file has been uploaded and indexed successfully. So this is a paper about cache augmented generation. Here we have a preview window to let you have an idea what the document is. And then let's talk about it. Hey, what is the definition of cache augmented generation in this document?
Okay, I will look for the definition of cache augmented generation in the document. Cache augmented generation is a method that involves preloading all relevant resources into a language model's extended context and caching its runtime parameters. During inference, the model uses these preloaded parameters to answer queries without additional retrieval steps.
So who is the author of this paper?
I will search the document to find out who the author of this paper is. The document doesn't specify the author of this paper. However, it does list authors of other works.
So who are they?
I will check the document to find out who the authors of the other works are. The authors of other works mentioned in the document are Tianyi Zhang, Varsha Kishore, Felix Wu, Kilian Q. Weinberger, Yoav Artsy, Pranav Rajpurkar, Jian Zhang, Konstantin Lopirev, Percy Liang, Jilin Yang, Peng Qi, Sai-Zheng Zhang, Yoshua Bengio, William W. Cohen, Ruslan Salahuddinov, and Christopher D. Manning.
So how is the performance of CAG in a small size of hotspot QA benchmark?
I will look for information on the performance of CAG in a small size of hot QA benchmark. The CAG system achieved a score of 0. 7,759 on the Hotpot QA benchmark with a small size.
The conversation is quite smooth, right? So imagine you have a bunch of product data and you have a RAG assistant like this. So all the service help desk job can be done very well with it. So let's start with a high-level overview of how the app works. Like all the previous demos, we have a front end written in HTML, CSS, and JavaScript, and a back end written in Python. The front end is a simple web page that allows users to upload a set of documents and display its preview in the window and manage the user's invoice input and Gemini 2.0 audio output, plus a text output area to display the model's response. The PDF file is uploaded to the server, stored in the server side, and meanwhile the document content will be indexed and stored for later retrieval. And there is a function defined to wrap the process of query the index and return the response, which is exactly the RAG process, and configure this function as a tool calling to the model initialization. Once the user voice input data is received, it will be sent to the Gemini 2.0 model to generate a function call response, and then this response will be sent to the RAG process to generate a query response, and that query response will be sent back to the Gemini 2.0 via Multimodal Live API to generate the audio output as a final response to the client. And with that audio, the function calling details will be displayed in the text output area. To prevent the wheel from being reinvented, I use the Llama index framework to build the RAG process. It highly simplifies the code implementation for a RAG pipeline and full supports the latest Gemini models and APIs. So with that 30-second quick start, I don't have to worry about the embedding, vector store, and semantic search techniques. Now let's dive into the code. If you are interested in running the entire project for this demo or the previous ones, you can find the source code in my GitHub repository listed in the description below. First, I will go through the backend server. So first of all, you should install all the necessary packages, but be very careful of their version because these packages are very dynamic changed. The first one is the Google Gemini, which is the 0.5.0 for Gemini model operations. And the Llama index, this is a core function for the Llama index, and Llama index LLMS Gemini, which is for the Gemini model operations in Llama index, and the Llama index embedding Gemini, which is installed for the Gemini embedding operation, and the WebSockets that is installed for the communication between the server and our client. So the server begins with these importing libraries, especially for the Gen AI method and the key methods that contain in the Llama index core package, and also the Gemini embedding and Gemini model for Llama index. Then we set the API key as an environment variable and define the LLM model Gemini 2.0 Flash EXP for the audio generation, and text embedding model text embedding 004 for the embedding operations. And then create the client by the Gen AI client method that used for communication with the API. And create the Gemini embedding model and LLM, which are used in the Llama index internal process. Be careful to set up the name for the model name for both methods. Should have models in front of the model name. Then we have two important methods that set the RAG logic for our app: build index and query docs. The build index is responsible for indexing the document we provide in the downloads folder. So when a PDF is uploaded by the client, the server will save it there and call this function to index it. After the index is created, we save it into a local folder for later use. The folder name is storage, so that we don't need to index the same documents every time the app restarted, because we can directly load index from the storage to restore the existing index. The query docs function is used to make a search into the docs index by using the index as query engine and to query the query string we provide to the function. And the response text will be converted to string and returned. Then we define the tool query docs dictionary, which is a tool that makes query docs available for the Gemini 2.0, so it will be called when a user question is triggered by it. Then we move to the core of the server-side logic, which maintained in the Gemini session handler function. This function is triggered for each WebSocket connection from the client. Inside the function, first we get the config data that comes from the client. For now, the client is only responsible for sending the response modality with audio or text to the server. And then we should add more data into the config, including the system instruction, which is very important to let the model knows that it should call the function that used to query the documents every time when user asks the question. So here I ask the model, you are a helpful assistant and you must always use the query docs tools to query the document and include towards any questions. It is mandatory to base your answers on the information from the output of the query docs tool and include the context from the query tool into your response to user's question. Do not mention your operation like I'm searching the document now. So you can refine the prompt to make it more stable to do the retrieval function. And we add the dictionary tool query docs that we create above into the tool section in the config. Then we can connect with the Gemini API by calling the client AIO live connect by providing the model and the config we create above. So we have the API session available for use. You should know that the session communication is also based on the WebSocket internally. Then we define a send to Gemini function inside the core logic function that handles all communication coming from the client to the Gemini API. For each message received from the client, we will decide which type of it. If it's a PDF file, the server will save it locally into the downloads folder, reindex the document, and send back a confirmation message to the user so the user knows the PDF indexing is finished. Or if it's an audio input, it will simply forward the data to the Gemini Multimodal API by using the session send. Then going forward, the receive from Gemini function manages the communication coming from the Gemini API to the client or to the API again. It listens to the Gemini API's response. If the model calls our custom tool, the function will know that and extract the function name and the argument, and then calls the query docs function to make a search on a document, and then returns the result data into a function response list, and that response list will be firstly sent to the client to display, and also will be sent to the Gemini API as an input of the function execution result. So this is the normal process of the RAG that uses the function calling capabilities of Gemini. And if the Gemini model just returns the audio or text without a function call command, the server will return that audio or text response to the client immediately to let the client to play the audio or display the text. And these two functions, send to Gemini and receive from Gemini, are packed into two tasks and being running parallel. In the main function, we use the WebSocket serve method to set up a WebSocket server at localhost 9084 with the Gemini session handler as the core logic processing, and using the async IO feature to keep the server running indefinitely. That's all for the server. Now let's transit to the client side, which is developed in HTML and JavaScript. The HTML structure includes a PDF section for the upload and also buttons and microphone controls. There is also the chat log element for showing the model's response. Most of the styling and design are done with the Material Design Lite library and CSS. So let's skip these details and focus on the JavaScript implementation. The main change on the client side is the PDF handling logic. On the window unload event, we set the PDF import change listener, which is triggered when a PDF is uploaded. On this event, the client reads each file, transforms to a base 64 string, and send it to the server. Use the send PDF message function we defined below. Then the list of the files that are loaded is displayed on the PDF list element, so the user can keep track of them as a preview window. The rest of the client code is very similar to the previous version, which have the send voice message function, handles audio capture and sending via WebSocket, and the receive function handles all the responses from the server, displaying the text and playing the audio. And we also have the PCM processor JavaScript file to support the converting the audio with a PCM format. It can directly played by the Chrome or other browsers. And the start audio import and the stop audio import that's controlled by the to talk button on the client to activate the audio recorder or deactivate it. Again, the complete source code is available in the repository listed in the description below. Feel free to explore it at your own pace. Now we can run the app. The procedure to bring up the web app is still the same, and which is very simple. Start the WebSocket server by running the Python file. Let's run it. You see your application running on port 9048 is available. Okay, that's successfully done. Now let's start the client by running the Python command. HTTP server on your project folder. Quickly you will see your application running on port 8000 is available. That means this client server has been set up. Now we can open the web page by access the localhost 8000. Upload the one file or several files and then start to talk. That's it. Feel free to leave any questions or creative ideas you may have in the comments below. Thanks for watching, and we will explore more Gemini 2.0 multimodal techniques in future videos.